We've seen generally two types of tests. There are the numerical tests that let us compare numbers, and the logical tests, not, and or. Let's talk about using those logical tests a little bit. To recap, numerical tests can test less than or equal to, and of course greater than or equal to, or equal to and not equal to. There are three logical tests. The first lets us negate the value of a Boolean. If it's true, it's false. If it's false, it's true. The other two let us find out if both A and B are true or either A and B are true. And we call those and or. Something we do all the time is take a point, say the position of the mouse, and ask if it's inside of a box. The way to find out is actually a great example of using these logical tests. So let me show you how to determine if a point is inside a box. We'll actually write a little routine. When we're all done, we'll have a little function called point_in_box. The inputs will be a point and a box. And the output is a Boolean, true or false, whether the point is in the box or not. Of course, I'm drawing the point as a big circle, but really all we're talking about is the point in the middle of that circle. How do we identify the point? Let's call it Px and Py. How do we identify the box? Well, we know we need an upper left, so I'll call those box left and box top, keeping these things short so I can use a big font on the screen. And then we need the box width and the box height. So those are all the inputs, and the output is a Boolean. So with these 6 floating point numbers coming in, out comes a Boolean, true or false. Are we in the box or not? So how do we do this? Well, what we want to do is compare a point against a box. Let's take two examples. On the left, we have a point that's not in the box, and on the right, we have a point that's in the box. Now, of course, we can eyeball this. Just by looking at it, we know that the point on the right is inside the box. But the question is, how can we write a procedure so the computer knows if the point is in the box or not? The way we do this is with a bunch of if tests, and then we use one of our new logical operators to combine them. Let me show you the process, and when we're all done, I'll show you the code. The general strategy will be this. I will compare the test point against each of the 4 sides of the box or the rectangle. So if we imagine that there are fences placed along the edges of the rectangle, I want to find out which side of each fence the point is located in. If the point is on the inside of all 4 fences, it's inside the box. So let's go ahead and do that one fence at a time. I'll start with the left fence, and I'll create a new Boolean called test L for test left. And its value is the x value of the point greater than or equal to the box left coordinate? And here I'm going to write out box left, box right, box top, because I have enough space, and I think it'll be a little bit clearer when we look at these lines. So let's look at the left case. Is the x value of the blue circle, the center of that circle, greater than or equal to the value of the left side of the box? In other words, is the point on or to the right of the left edge of the box? We'll test this for both boxes. In the middle between them, I'll build a little scorecard. So this will tell us whether we are or not to the right of the left edge of the box. So let's look at the case on the left first. Graphically, I can just draw the fence, and then I can think of the yard inside the fence. This orange region represents all the points that are to the right of the left side of the box. These are all the points with an x value greater than or equal to the box's left edge. Well, is the x value of that point to the right of that line? No, it's not. So the Boolean is false. I'll mark that in red. And I'll draw a little red rectangle along the wall on that side to remind us. Let's look at the other case. I'll do the very same thing. I'll draw the fence. I'll look at all the points to the right of the fence, and I ask, is the point we're testing to the right of the fence? Why, yes, it is. And so I'll draw a little green box there to remind us of that. So here's the situation we have so far. In the big picture on the left, the point is not to the right of the left edge of the box. In the big picture on the right, the point is to the right. Well, we're just going to repeat this for the other sides of the box. So I'll tell you what, let's test the right-hand side. I'm going to ask, is the x value of the point less than or equal to the right side of the box, which is just the left point plus the width? Well, let's build our little scorecard, drop down the fence. Look at all the points to the left of the fence. Is the blue point to the left of the fence? Yes, it is. So that's true, and we'll mark it in green. Let's look at the other guy. Draw the fence. Look at all the points to the left of the fence. Is the test point to the left of the fence? Yes, it is. So we'll mark that in green too. So here's where we are so far. We've tested 2 of the walls. Well, we just tested the other 2 walls in the very same way. Let's test the top. Is the y value greater than the top of the box? We'll put up our scorecard between the 2. And on the left, I'll draw the fence, and I'll look at all the points with a y value greater than the location of the fence. Is the test point below the top of the box? No, it's not. False. And we'll mark a red box there to remind us. How about on the right? Is the test point below the top of the box? Yes, it is. True. And so we mark that in green. And here's our situation so far. Finally, we'll ask, is the point above the bottom of the box? Once again, we'll put up a little scorecard between the 2 test cases. On the left, I'll draw the fence, and I'll look at all the points that are above the bottom of the box. And sure enough, this one is. So true. Mark it in green, draw a green box. How about in the other case? We draw the fence, we look at all the points above the bottom of the box. Is this one above the bottom? Is it in the orange zone? Yes, it is. True. And so we draw a green box there. And this is the final result. So now, how do we use these results to tell us if the point is in the box? Well, look at the 2 columns in the middle. On the left, we have some reds and some greens. On the right, we have all greens. The point is in the box if it is on the inside of all 4 fences. We create a new Boolean called point in box, and it's just anding together of the 4 values. Let's show this graphically. Under the scorecard, I'll put the results. In the left-hand column, we ask, are all 4 values true? No, they're not. And so the result is false. On the right-hand column, we ask, are all 4 values true? Yes, they are. The result is true. So for the left-hand case, point in box is false. But in the right-hand case, point in box is true. And that's how we write a routine to find out if a point is inside the box. To convert this into processing, we just take those 5 lines at the top and wrap them up in a procedure. So let's do that. First, I'll write a little comment to remind myself of what this routine does and what the inputs are. Then I'll write the structure of the procedure. I'll call it point in box. I know it returns a Boolean, and it takes these 6 inputs: the point, x and y, and the box, left, top, width, and height. Now I just write the 4 Booleans we just created, testing the left, right, top, and bottom against the 4 sides of the box. I create a new Boolean just by anding these 4 together, and I return that new Boolean. I know I went through this pretty quick. The slide is here, and you can always come back and look at this code in more detail. This is a great use of the AND construction because the point is inside the box if it's on the inside of all 4 fences. Just because we're talking about points being inside of things, the other great test is to find out if a point is inside of a circle. This doesn't use the logical constructions, but it's just so useful and it fits in with what we're talking about so well. I'll describe the recipe to you here. So how do we know if a point is inside of a circle? All we need is the point we're going to test and the circle. Now, how do we describe these? The point, just like before, we'll describe as x and y. The circle we describe with a point, circle x, circle y, telling us the center of the circle, and the radius of the circle, which I'll call circle radius. So those are 5 floating point numbers. Those 5 floats are the inputs to the procedure. What comes out is a Boolean, true or false, whether the point is inside the circle or not. How do we find out? It's basically high school geometry, and we're not going to go through that. I'm just going to mention that there's something built into processing that does most of the work for us. What we want to do is to find the distance from the center of the circle to the point and compare that to the radius. If the point is further away from the center than the radius, it's outside of the circle. If it's equal to or less than the radius, it's inside the circle. So how do we find that out? Here's 2 cases. The point's outside the circle, the point's inside. I'm going to write a little test that computes the distance to the center. This is the distance from the point to the center of the circle. And notice that I'm calling this function dist. Dist is a built-in function in processing. It takes 4 arguments, xy of 2 points, and it gives you back the distance between those 2 points. So dist px py circle x circle y gives us back the distance between the point at px py and the center of the circle, circle x, circle y. And I'm writing that result in red because I was using red to show you that line. Now I'll compare that distance to circle radius. If the distance to the center is less than or equal to the radius, then point in circle is true. So let's compare this to our two cases. First, we find the distance to the center between the point and the center of the circle, and we compare that to the radius. And clearly it's bigger. The distance is bigger than the radius. So point in circle will be false. In the right-hand case, the distance from the point to the center of the circle is fairly small. Compared to the radius, it's certainly smaller than the radius, and so point in circle is true. Converting this into code, it just means taking those two lines at the top and putting them into a procedure. So we write it down by starting with a little comment to remind us. We write the function declaration. It returns a Boolean. It's called point in circle, and it takes these 5 floating point numbers. And then we just type in the two things we just saw. We compute the distance from the point to the center of the circle. We store that into a float. And then we compute a Boolean called in circle. And that simply is the test, distance to circle less than or equal to the radius. If it is, it's true. If it's not, it's false. And then we return that value. The two little functions that we've just seen, testing if a point is inside of a box or a circle, are so handy you'll find yourself using them all the time. I kind of wish that they'd been built into processing, but they weren't. So if you need them, you'll have to provide them in your program explicitly. And now you have the recipes. In part 2, we'll get back to using and or tests.